Okay, a couple more problems on simplifying radicals and factoring that I noticed people were a little bit challenged by. Two factoring problems first, and then some work with rational equations and also with radical expressions. So the first factoring problem I want to do is k to the 7th minus k to the 3rd. So really important here, I notice right away we have a common factor of k to the 3rd. So I'm going to factor that out. Please be sure you don't forget to write that down. That leaves me with k to the 4th minus 1. So this can be further factored. And this is a difference of squares. Now, I'm not going to forget my k to the 3rd. He's right up here. He's just hanging out. My two factors here, I have k squared minus 1 and k squared plus 1. K squared plus 1 does not factor further over the real numbers, so I will leave that be. K squared plus 1, however, does. I'm going to circle k squared plus 1, and I'm going to factor the k squared minus 1. That does factor over the real numbers. That is a difference of squares. So that's that factorization. Circling here, I have my 4 factors of this expression, and overall, the fully factored expression is k to the 3rd times k squared plus 1 times k minus 1 times k plus 1. Now, because this is multiplication, of course, we know that the order does not matter. However, if you want your expression to be considered fully factored, you need to show all 4 factors here. So this is the fully factored form. If you just get this far, this is not enough. So you want to be sure that you finish by getting to that final step right here. Okay. Moving on, another one, and this was another one that stymied a lot of people. So first of all, I think the most helpful thing to do here is to consider that there are 2 possibilities. First possibility to think of is that 1/4 is a perfect square, 25 is a perfect square, so this could be a perfect square trinomial. That's one option. Your other option is to say, I don't want to work with fractions at all today, so I'm going to divide by 1/4. That's the approach I'm going to take. Again, the other one I would still consider to be fully factored. If you factor out the 1/4, however, you are going to get x squared minus 20, because dividing by 20 is the same as multiplying by 4, plus 100 z squared. And then it may be a little bit easier, because we do have those integer coefficients, to see that this is a perfect square trinomial. And then I have x, because this is a negative coefficient, negative 20, that tells me that this is going to be minus 10z. Now, I will accept either 1/4 times x minus 10z quantity squared, or you could write out x minus 10z 2 times. I'm actually going to put a little line through that z. Either one of those is okay to do. So that's a couple of quick factoring problems.